So the last section that we look at in Chapter 2 in the geometry unit is 2.6, the solid geometric figures. So solid geometric figures are three-dimensional figures, and we are going to be looking at calculating the volume and surface area of these figures. Now we'll be only doing certain types of solid geometric figures. So the two-dimensional shapes that you've looked at so far, triangles, quadrilaterals, and circles, are going to become the faces of these solid geometric figures. Faces being the sides that you see. Say if you look at a box, it has a side that's a rectangle. So here are some various solids, and we're looking at formulas for the volumes of each of these solids. Take a look at this one. This is a solid rectangular based prism. There's the base. It's made up of a rectangle. And what you will notice is the sides are perpendicular to the base. They are all the same length, right? And the top is an identical rectangle at the top. This forms a rectangular based prism. Okay, and so its volume is made up of the area of the base, which is the length times width, multiplied by how high it is. And in general, for rectangular based prisms that have perpendicular sides, we say that the volume is the area of the base multiplied by the height. And so therefore, the shape of the base can change. Could be triangular. In this case, we have a circular based prism, and we have perpendicular sides, and we have the exact same circle at the top. Notice the formula has the area of the base, pi r squared is the area of a circle, multiplied by height. Okay, so these are some generalities that I want you to be aware of. The volume of a cone is 1/3 pi r squared. A cone has a circular base, so pi r squared is involved. But because it's a cone, it's 1/3 and multiplied by height. This is the distance from the vertex at the top to the center of the circle. That's the height. For a sphere, 4/3 pi r cubed. All you need to know is the radius of a sphere from there to there, and you can calculate volume. Okay, now surface area, in particular for a sphere. What you want to do with any of surface area questions is think about picking apart the solid and laying out all of the faces. So for instance, a cylinder is made up of circles, two circles, and something that wraps around it. And in fact, it looks like this. If I unwrap a cylinder, I end up with a wrap. And you can do this if you roll up a piece of paper, and this part is the distance around the outside of the circle. What is this length? If we look at that length, what would I think of this length in terms of this distance around here? Circumference, right? And circumference equals 2 pi r. And we said that the area of a rectangle was the length times the width. And in terms of the way it's labeled here, that would be 2 pi r times h. So the surface area for a cylinder is 2 of these added to 2 pi r h. 2 pi r squareds plus 2 pi r h. The surface area for a sphere is 4 pi r squared. Can't really break it down too much like we did the other one. This is the radius in here. For a cone is made up of one circle at the base, and then this wrap part that goes around. You think of that like one of those cups, you know, when you get a drink of water from a little machine and it has those little white cone cups. That's what I envision for this. If it's open, you're not including the circle at the bottom. If you close it, then you include the circle. So there are two ways to look at the surface area, either opened or closed. This is including the circle, and this is just the cup part of it, right? So S is a value you haven't seen. Well, you have seen it. It meant arc length. In this case, it means something else. It means the slant height. So a cone has a height which is perpendicular from the vertex to the radius. It also has a slant height. If I break this into a right triangle, and we have height and radius, slant height is the same as some other value that you already know, right? Hypotenuse. Okay, so you may have to break down a cone into the right triangle that is spun around the circle to form it. So there are two different types of surface area. Total surface area includes all the faces. Lateral surface area does not include bases. This is a breakdown of the short forms used for the formulas from your textbook. Total surface area as capital A. Lateral surface area is capital S. Capital B is area of the base. Lowercase p is perimeter of the base, and S refers to slant height when you are looking at formulas for geometry and solid geometric figures. There's a clip of what is in the book. Just a little picture of the formulas. And the others. One of the things we haven't referred to too much yet is pyramids. So we'll talk about those a little bit, because I did talk about prisms, but not pyramids. You can ignore this section on frustums. I'm probably not going to get into that. Notice the word regular in the pyramid. Regular means that the base is equilateral. So in this case, that's a square. If it was a triangular based pyramid, it would be an equilateral triangle on the base, all going to one vertex point at the top. Okay, so regular in this case means base is equilateral. Right means height is perpendicular. All right, so here's a couple practice. If you want to practice that, and then so stop the video, and when you come back after you look at it, we will discuss it. So lateral surface area, remember that meant do not include the base. So therefore, the lateral surface area for a cone is pi rs, just the cup portion, okay? I'm not putting on a circular base. And I'm only referring to it as cup as so everyone can visualize that little white cup, get that drink from the water machine. That's a cone with no circle at the bottom included in its surface area. Well, before we can do that, we haven't been given S. So we have a right triangle. S is here. Height is 22.3 centimeters. Radius is 15.4 centimeters. We need to calculate S. If you sketch a diagram of this cone, then you can see those values that are given and S is not given. S is the hypotenuse of that right triangle, and so therefore we calculate it by using Pythagorean theorem. Now we can calculate the lateral surface area, capital S, using pi, r, and s. Make sure that for an area that you have units squared. Okay, calculate the volume of this sphere. It has a radius of 10.5 centimeters. Pause the video, give it a try. The volume of a sphere formula is 4/3 pi r cubed. Remember, only r is cubed. 10.5 is cubed, multiplied by pi, multiplied by 4/3. This can be done by multiply by 4, divide by 3, or you can use your fraction key, right? Maybe I should do that somewhere else here. So 4/3 on your calculator, you can use the 4b/c3. That's probably the best way. Find the pi button and multiply by 10.5 cubed. (4,849 centimeters cubed). Regular pyramids, all right? A regular pyramid is the base is a regular polygon. That means it is equilateral. If it's a triangle, we call that an equilateral triangle. If it's a square, it has all 4 sides the same. A regular pentagon has all 5 sides the same, and so on. That's what the word regular refers to when discussing solids. The lateral faces are congruent triangles. Congruent means they are exactly the same. I really encourage you to try drawing these things. So, for instance, a triangular pyramid, all these sides, a regular one, all 3 sides would be the same. The way I do it, if I offset it a little bit, notice I didn't do it straight up, and put the vertex up here, and you just have to connect the vertex to each corner. And you have a triangular based pyramid. And so the center height would go from here right down to the center of your triangle and be perpendicular. There's a height. So drawing them is really key to understanding them. There are some drawings as a square based with the height to the center. The slant height of a square based regular pyramid is up the center. So it's the height of the triangle that is a face on the side. If you could picture just looking at that one side right here, the height of that triangle is S in this one. Same here. Not the edge. Something to keep straight when working with the formulas for pyramids. A right prism, the bases are equal and parallel polygons. Okay, just like the very first shape we drew, a square-based or rectangular-based prism. I've drawn it as a parallelogram, but that's because I'm getting kind of a side view or an angled view at my rectangle. If we draw the exact same one above and then connect corresponding vertices, you end up getting a 3-dimensional rectangular based prism. And right means you have perpendicular sides. Okay, they're straight up, all of them are perpendicular. we are not dealing with formulas for anything that does not have perpendicular sides in a prism. Okay. So that means we're not dealing with anything like this in this section, okay? A triangular based prism, so we have triangles on each end and we have rectangles adjoining the equal triangles. There would be another one here, right? Inside that tent. All right. So I encourage you to really try drawing some of these figures, even if you're looking at one that's on the screen and you copy it, but find a way to draw them. And especially, you know, in architectural, you're going to be drawing a lot anyway, so you really should be able to draw three-dimensional figures as well and be comfortable with that. And thanks for watching. Bye-bye.